Start now, sir. Thank you. All right, guys. I hope everyone is back. We just in the previous session we looked at the basic motivation behind optimizations and the three basic ideas: safety, profitability, and opportunities where we can get it. We also looked at 3 or 4 loop optimizations. What loop transformations we looked at? Loop unrolling, loop interchange, loop fusion. Okay. You will say, hey, you know what? This guy showed a 2-liner program and asked us to apply, right? In real world, does it really show up code like that, right? What we will do now, we will take a reasonably popular, probably the most popular code and we'll apply these optimizations. I'll do that, but before I forget, yesterday evening, on the day before, I think I sent an email asking you to install IMOP and some related things. Everyone has done that? Anyone who has not done? 1, 2, 3, 4. Uri Baba. Why not? Not able to, not able to install. Huh? But we need to do that. We have to use that today. Okay. Those of you who have done, how many of you have completed demo 0? Because it has given steps, download and then run. Now, demo 0, how many? 1, 2, that's it? Only 3, 4? We'll end up wasting more time otherwise setting up things. See, at least if we have half the students had completed demo 0, we would have paid you in pairs. You would have actually written a compiler pass yourself. You would have done, my goal is, whatever you are learning, this loop unrolling, the loop fusion, you will actually do it in the code. It just, and this IMOP is a real compiler framework, right? Maybe we'll try. But how is the question, right? I mean, if people haven't even downloaded. How many of you have downloaded with Eclipse? Okay. No, you do any later Java is okay. 1.8 and above is okay. Yeah. I mean 1.8 was, when we started working on it, but we need at least 8. Z3, Z3 even if you haven't installed, I'll still be able to serve. Oh, good. Okay, we'll try. Okay. So matrix multiply. Okay, you would have seen this code so many times. If you have not seen it many times, if you are going to spend time in different applications, right? Matrix multiply, say in most of the AI ML codes, most of the operations are matrix operations. Matrix multiply is probably the most popular one, even there, right? Anyways, so this is using a syntax which is slightly different. I chose this syntax which is easy to read. I goes from 1 to n, increment of 1. J 1 to n, increment of 1. This is array C sub ij. So let's say I want to multiply A times B. A, B are matrices of size n. I want to multiply them, add them to C. Right? So C equal to A times B. That's the matrix operation. So for each I, for each j, I will initialize an element of Cij to 0. Then for different values of k, Cij equal to Aik times Bkj. Standard matrix multiply code. Assume that they are all floating point numbers. Okay? Any questions? Syntax is fine. I mean, it's not C syntax, but chalega, I think. How many floating point multiply operations do I have there? N cube. How many loop? How many branches do I have? How many branches do I have? N cube, n square, n. Isn't it? This for this loop you will have total n cube branches. For this loop n square, this loop n. Okay. Sorry. Yes. How many loads do I have? I have to load this fellow. I have to load this. I have to load this 2n cube. And I am assuming that Cij will be the same thing will be used again and again. So I am assuming it's the yeah, sure. Yeah, sure. Right. So I have total n cube floating point multiplies, n cube floating point additions. Okay, so 2n cube floating point operations, n cube loop increments plus n square plus n, but the big factor here is the n cube and n cube loop increments. ठीक है? In each iteration, each innermost iteration, I have 2 loads and 2 floating point operations. क्या कर सकते हैं इसका? We have studied some optimizations. What can we do? Before loop interchange, let us first see if we can unroll. Let me unroll the innermost loop. K goes from 1 to n. K increments by 4. I'll do k, k plus 1, k plus 2, k plus 3. Or if you could have done 1 n 1 and done k plus plus k plus plus, both are same. Okay, not much of a difference. Right? What's the, after unrolling, how many branches do I have? How many branches do I have? Yeah, you too. How many branch instructions? In a loop, when I say branch instructions, right? So if you look at the loop here, hello. Why is it? Ho, 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 ho. Yeah, if you look at any loop here, right, there are 3 loops here. If you look at any loop of these 3 and I say branches, what I mean is at the end of the loop, there is jump back, correct? Similarly, here there is a loop, the do is a loop, the do, it's in Fortran it's called a do loop. In C like we call it a for loop, in Fortran it's called as a do all loop. So it's a do loop, no difference in terms of for loop. We can treat it as a for loop if you want. Here also, I have n branches. So this one is called 3 times, so it's n cube branches here, n square branches here, n branches here, right? So now how many branches are there in this? Hmm? N cube by 4. So number of branches are n cube by 4. Correct? Good. And what about uh, floating point operations? Has it changed? It hasn't changed. It's not constant. It hasn't changed. It's still 2 n cube, n cube multiply n cube addition, 2 n cube floating point operation. Correct? You seem to be very quiet, my friend. Why? You are following what's happening? Good. So my number of floating point operations has not changed. My branches have changed. What about loads and stores? Yes and no. If I am accessing A sub ik, if assume there is a forward cache line, then once I load it, these three are free. It's more visible. It's not visible. What about B? Hmm? For B, I am doing bk plus 1, k plus 2. So they are not aligned. This is cache aligned. This is not. Correct? So flops hasn't changed. Loop increments and loop branches have changed. In each iteration, I am doing 8 loads, right? And memory traffic Cij is reused, not surprising. This is also cache aligned. Okay. No, 8, no. 1, 2, 3, 4, 5, 6, 7, 8. Of these 4 are from coming mostly. First one will be maybe a cache miss. The others are. So the cache traffic is better for AIK. Yeah? Fine? So far so good, everyone? So we will be doing some pretty dirty code looking very soon. Just make sure you are fine with this. उसके बाद वाला code, it will look very different. Check with your neighbor. Quick look at your neighbor. All fine? Any neighbor is not happy? Okay. Now what we will do, let's see what we can do for B. Okay. I will do a bunch of things. I wanted to do it actually step by step on the slow on board, but maybe no. So what I am doing, look at this way. This I and J, I interchanged. Okay. I after interchanging the I loop, I unrolled. I loop times 4, and the 4 iterations of I pushed it inside. So basically, so look at this, these two are unrolled, the K loop remained the same, and then this whole thing was my previous body. This whole thing, just for easy fitting it in the slide, I kept this whole statement as a single statement. So this is for I, this is for I plus 1, this is for I plus 2, this is for I plus 3. So what all did we do here if you pay attention? I unrolled the K loop and I loop. Okay. What else I did? So I interchange the loops. I did loop interchanging. Then I did something more. Let me take a pen and explain it. Sorry, ma? I have unrolled twice. I have unrolled two different loops. I have unrolled this loop and this loop. By the way, here there is a Cij0, let me just, there is a typo there. I should have fixed it. So that Cij0 should become Cij equal to 0, Ci plus 1 comma j equal to 0 and so on. Okay. So all four, C I plus 1, I plus 2, comma j equal to 0, C I plus 3, comma j. So there is a typo here. Huh? So we are initializing I comma j, I plus 1 comma j, I plus 2, I plus 3. Yeah. But there is something we did, I want to go over. This I and j we interchanged. If I interchange, the loop will look like this. Do j, do I. This is how it will look. Next, what I did, I unrolled this loop by a factor of 4. So what it became, the do j remained as do j, the do I became I equal to, I starts from 1 up to n with a increment of 4, and the body of this, the body of it, I will have 4 copies. I will have 4 copies. What are the copies? Let us say this whole statement, I am marking it as S. The do, and this is S. Okay, do K S. So the loop, the body will become C I j equal to 0, do K S for I. The body, this will be repeated now. C I plus 1 j gets 0, then do K S I plus 1, then C I plus 2 comma j, do K S of I plus 2, then last C I plus 3 comma j gets 0, the do K loop S I plus 3. Do you see what we did? I had do j, do I, and I had a do K here. The original code was like this: do j, do I, C I j equal to 0, and do K some statement S for I. This is the original. That code, what you see on the board, is this. On top of it, there is a do. This. So this one, just focus on this part now. Do I loop. The do I made it 1 and 4. I have unrolled it, factor of 4. If I unroll, the body has to be repeated. Body repeated once, twice, thrice, 4 times. Right? Now I moved this to upstairs, so I get this one. What do I have now? Do K, do K, do K, do K. K 1 to n. So whatever the code there, K goes from 1 n 4. ये वही है, ये चेंज नहीं हुआ है. Same, do K 1 n 4. Around. Si is this whole code. Si plus 1 is replace this I with I plus 1. Just this code, in place of I put I plus 1. So when I say Si, I am saying that code where I is this thing. Okay. So now I just replicate this 4 times. Copy. This is 1, 2, 3, 4. Right? Unrolling. I moved theCijs out, kept it in one place, and then I have pay attention. Ouch! No, not pay attention how I drop this thing, but now pay attention to the do while loops here. Do while loop, this do while loop. The header is the same. The bodies are independent. I can do loop fusion. Similarly, I can fuse this and this also. Once I fuse all the 4, this is what I get. Inside the do k loop, sorry, si plus 1, si plus 2, si plus 3. Right? What did I do? I did loop interchange, loop unroll, loop fusion to get this. Now you see what has changed. How many branch instructions do I have? N into n by 4 into n by 4. N cube by 16. Number of branches have come down. And the increments. How many floating point operations are there? Have I reduced any? Floating point operations have not changed. Correct? Aha, they are taking attendance after every session. Good here. They are very serious. Good, good, good. All right. Now let's look at the cache. Right? Again, remember I have a 4-word cache line. When I bring in a sub ik, I'll get k plus 1, k plus 2, k plus 3. Correct? Yeah. So a k plus 1, a ik plus 2 and ai k plus 3. These 4 are, once you get this, these 3, the remaining 3 are coming from cache. Similarly, if I get this one from memory, these 3 are coming from cache, right? These 3 are coming from cache. Similarly, this one, if it comes from memory, these are coming from cache. This comes from memory. These 3 are coming from cache. This is same as before. If you remember, when we are unrolled the k loop, we could see this. What happened to the b? B was the problematic one, if you remember, right? Let us see what's happening with B. I am loading bkj. If I load bkj, what will come in the cache? Bk j plus 1, bk where? Bk will bring in bk j plus 1, j plus 2, j plus 3. I am not using them here yet, but the bkj is reused. Bk plus 1j is reused here. Bk plus 2j is reused here. This is one load, load, 4 loads, reused 1, they are kind of reused in all the things. So in this body, 4 elements of B are loaded. How many elements of B are loaded? Only 4. The rest are from the cache. Actually, I can just reuse. I don't even need to have a load because this BKJ and this BKJ are the same. I can load this. I can write it as some 4 different variables and reuse them. So B is reused. What about A from the cache? So I have to do 4 hard loads for A. If I do 4 hard loads for A, 1, 2, 3, 4, rest of them are from the cache. For B, if I do 4 hard loads, that is from memory, if I bring in 1, 2, 3, 4, the rest of the B accesses in the body are, either from the cache, or a compiler will simply replace, load it once and reuse that variable at so many places. No, not even loads. Loads have gone. So what I will do, let's say I will write it as B1 equal to B, rather B0 equal to B kj, B1 equal to B k plus 1j, B2 equal to B k plus 2j, B3 equal to B k plus 3j. Now I will introduce those 4 lines at the beginning of the code and use B1, B2, B3, B4. Sorry, B0, B1, B2, B3, B0, B1, B2, B3, B0, B1, B2, B3. No loads. The number of loads for B have become 4 instead of 16. Isn't it? Instead of 16 loads for B, in each iteration I have only 4 loads for B. Instead of bringing 16 elements of A array, I am bringing only hard brings, I mean from memory only 4 are coming. 1, 2, 3, 4. Rest are coming from cache. Has the complexity of the program changed? No. Complexity hasn't changed. The constants have changed big time. Correct, absolutely. See, what I want to kind of reinforce, we study complexity of a program, of an algorithm, right? This complexity is only telling us one small part. Which part? It's telling us, it's giving an idea of how much time it may take. I may be able to optimize the code without even changing the complexity. See, basically, when you are looking at a complexity, you will just say every operation is the same cost. Every operation is not the same. Every load is not the same. Every store is not the same. Correct? Yeah, so the flops haven't changed, increments have reduced. So the Cij traffic, as usual, I am reusing. Aik are from cache, Bkj is reused. Right? The best part, this is done automatically. A compiler, see, we learnt what is loop unrolling, when we can do loop unrolling. We learnt what is loop interchange, when it is safe to do so. We learnt loop fusion. But combining them in this way, right, requires more work. We won't cover it in this class. But I want you to be aware that it can be done. Okay, so what we are learning in this class are some basic blocks. And I am telling you, we can use those basic block optimization, some building blocks to make bigger transformations. Right? Any questions? No? Okay. My initial plan at this point would have been to actually do a hands-on where you will write your own loop unroller. But how do we do it? Any thoughts? How many of you have Eclipse installed? Eclipse plus what is it? IMOP. Eclipse plus IMOP. Okay. Huh? Yeah. Eclipse. With Eclipse, it's going to be much easier without unless you want to use Vim with plugins. See, okay. Can we pair up? So what I'll do, I'll go with I'll kind of cover a bit of a tutorial, okay, and then we will ask you to do some hands-on work, okay. Um, all right. So this is we will have a quick. We can unroll. See, there is always we can further unroll. How much to unroll? Why only a factor of 4? Why not more? Why not less? Right? These are important questions, and we are not. Code size is an issue. Okay. Here is a statement. If I unroll too much, it can slow down my code. Who can? What did I say? I didn't say it will. Code size will become big. Of course, code will become big, but I'm saying if I unroll the loop instead of 2 or 4, let's say by some very large number, I don't even know what that large number is. I'm saying it can slow down. Can you guess why? What about it? How many of you have heard of this thing called instruction cache, iCache? Not many. See, like data cache, when we fetch some data, it comes from memory, right? The code also comes from memory, of course. When we are fetching an instruction, it may be coming from memory or from my iCache, instruction cache. If the instruction is not present in the iCache, I bring it from memory to iCache. If it is present in the iCache, it's much faster. Let's say I have a loop, and the body has exactly the number of instructions that will fit in the iCache. Then for the throughout the loop, I have no cache misses, or after the first iteration. After the first iteration, I have no cache misses. But let us say I unroll. What will happen? Exactly. So now the loop body does not fit in the iCache. So constantly for every instruction in the loop, I have to fetching from memory. So it will slow down. So it's not that loop unrolling always says it can speed up. It can also slow down. Am I making sense? What's your name? Vani. Are you following what I'm saying? What's your name? Are you following? Okay. Do you understand why there can be a performance degradation? Right? So now the question is, how much do we unroll? These are typically some heuristics. For the time being, we will not break our heads for that. But be aware that it can have a negative impact also if you are careless. Right? Okay. Any other questions? Maybe I should have asked for any questions before we. Maybe we should do one thing quickly. I mean, I forgot. Just check with your friends once, otherwise we will have one more discussion, I don't mind. Yeah, check with your friends that this code is same as the previous code and it's more efficient. Discuss with your friends specifically about the 3 transformations we have done. unroll, interchange, and fusion. The fusion what was described in the on the board. Check with your friend. Oh, you're installing now, is it? Demo 0 ready. Demo 0 ready. राहुल एक बार चेक कर लेना. Your which version of Eclipse, which version of Java? Uh, I think it's the modules. It doesn't like, maybe there are other modules files there. Just check. What about you, my friend? Not opening. Okay. How about you guys? Okay. How about you? What's your name? Rana. And you are? Krishna. Oh, nice. Okay. Let's do that. Yeah, right. I'll do one thing. I'll just have a quick introduction to IMOP and then I'll request you to come over. Okay. All right. Are you fine with this, everyone? Yes, I see many of you seem convinced that this is better, but some I still see some confusion. You're fine? Okay. You had a question? Okay. We will do one thing for some of you are not able to follow the steps of installation. We'll do one more of those things. We'll take you through once more. Okay. Okay. We'll talk about IMOP. This is the framework on which we will be implementing some of the things we have learned. Okay. It's a framework designed in my group. My student Aman was the lead developer here. It's probably the only compiler framework from India which is A, open source, B, available to others, yeah, and recognized by people around. Yeah. See, there are lots of compiler frameworks. You may think, hey, why one more? We found that those were not convenient to write many of the passes. Okay. So, if you start working in larger pieces of code, you will find when the code is big, introducing your own code within that can be complex. So, we followed some good design decisions that we feel are good, and we have this framework, right? So, why are we using IMOP here? The idea is simple. We believe you can write reasonably important passes very quickly, as you will see in the tutorial here. We believe that IMOP can be used for fast prototyping. You have a new idea, say unrolling or whatever, you come up with your own idea, you want to quickly implement. It's very easy. By the way, you learnt about scanning, parsing, this checking, that checking, and all that. No, it's not that when you have to build your compiler or when you want to build your own pass, you have to do all that. That will be done by some other framework. You can just bring in your own pass. Okay, it's not that you have to do everything from scratch. The framework is written in Java. Okay. Um, we believe writing code in Java helped us avoid lot of bugs. In C, C++, there are issues like you write in an array, you cross the array boundaries, you don't know what's happening. I mean, the array out of bounds, writing to unallocated memory, double freeing, etc. All those things in Java are handled much better. Okay. Um, for this tutorial, if you are familiar with C++ or Java, you will be able to do. Okay, we don't require any major OO or Java concepts for this tutorial. Okay, so we'll do one thing. We'll start with the IMOP setup. Um, I'll request Rahul to come run us through. So, how many of you have done the Git cloning of IMOP compiler? Everyone? If you have not, at least you should have someone sitting next to you who has done it. Last row, what's the status? Downloaded IMOP? How about you? IMOP not yet downloaded. How about others? Can you do one thing? Can you join? Yeah. No, correct, but they do not even have installed IMOP. Will it not take time? Do you have internet access here? Ma, all four? Then can you come over? He will show step by step. If you have not done those steps, do it. And if you have already done the project demo 0, right? Hey, can you do one thing? Send me the updated zip file of the demo files by email. Okay, I will be posting a new set of demo files. Okay, by on WhatsApp. Please download them to your machine. Bolo? What's that? Ah. Oh, this has to be imported, is it? Why don't you add it to the demo too? No problem. I'll do it now. I mean, it's in demo 2, right? Okay. Yeah, I mean, that's much better than asking them to, right? All right. I hope you can access your. Your- oh, yeah, that's. Yeah, for now you can avoid. Z
install, sir?
Oh, you know,
So I hope you guys can hear me.
yeah. No, sir. The mic on?
Let's get started. So cloning will not take much time.
No, just go back. Every now and then we just step. We go step by step. Please make sure. Who are not yet cloned, please raise your hands if you're not yet cloned. Done? All four?
Yes.
Everyone is done cloning. At least you will see the tested of my your clone. Cloning done. What's up? Here. Cloning done. Now I'm thinking maybe they can join all the
Pairs.
teams.
That should be fine, sir.
Cloning. Okay. We are in trouble because four of them will be totally left out.
They can use mobile hotspot for internet. These steps won't consume that much amount of internet bandwidth. People can connect to your hotspot.
Cloning done. Okay, we have at least one. What between you two we have? Cloning done. Good yours is done. Very good. How would you? Let's install Eclipse also.
Eclipse will take time. Better to start installing Eclipse. 200 MB. Not much time. Yeah.
Okay, so after that, what do we do?
The next step would be to do and clean.
No, CD.
Yeah, cd to this imop compiler folder. We can ignore the Z3 build steps for now. It can be used as a further exploration for you guys. So we can switch to fifth step, building the imop using ant. Just make sure you don't see this module info.java file in source directory. It's not there. So
Yeah, in the SRC directory, please see that there is no modules file. Okay, otherwise I got nothing like it. In case, yeah.
so next step is to do and clean.
Everyone done anti and ant build.
Just and
Do the ant. Done. If you're done, yeah.
and command should show the build is successful. So we are done with the terminal level changes. Now we have to move to the Eclipse. So I have my Eclipse opened here, but yeah, I will just get started with the fresh setup Java project. Do the file new Java project in Eclipse. File new Java project. And the project name you can add whatever you want to add. For this thing I will be adding the IMOP compiler. I am removing this, unchecking the use default location and try to browse it to the cloned IMOP compiler directory. Okay. So this is where I have cloned IMOP compiler. I'm just opening it. This will allow me to go to the next step here, as you people can see it.
Some issue here. But this is the location of another project. You already done this. Okay, no problem. Just copy that one more. You see, you already have the.
Yes, sir.
बेसिकली जो भी विंडोज़ यहाँ पे खुला हुआ था इक्लिप्स के इन्वायरमेंट में वो हटाया था यहाँ पे
He is not able to close the project and open a new project.
Close and open. File. New.
No, he did new. It says the project is a new Java project. Some whatever, right? So,
IMOP and browse.
yeah, this is the one. Just say open. It says it's already another project.
Yeah, so you have to delete the, that's what I was doing. You have to delete the existing project and try to open the new project.
So how do you delete an existing project?
It should show.
Right. So for him, that navigation is not showing up.
I think it will be visible.
Can we reinstall Eclipse over it?
Reopen the Eclipse.
I tried using it.
So you can
Yes,
delete
yes,
this.
you can do.
Yeah, you can directly import. So yeah, I'm just deleting my project so that I can show the fresh installation for everyone. So yeah, Java project. So I hope these steps are clear. I'm going to the next step. Next step allows me to read this entire repo properly. It will see all the jar files. It see this IMOP compiler as a Java project properly. And when we do finish this thing, we see this thing showing up here on the left side.
Let's take a pause here. Everyone has opened this project in Eclipse. Anyone who has not and needs help? Okay. The answer is yes, you can. There's no issues. Just that the thing they already set up in Eclipse will be Eclipse import only new project. if you are done with the steps 4, 5 and 6, right? Then run the demo. Can you see the instructions that follow demo? What are you maybe you have to face? How about you guys now? Eclipse, okay? Are you able to run the demo 0? Follow the steps, no? Yesterday I sent you a PDF, no? Can you go to the next step? How about you? How far are you done? Demo 0 done? Okay. I have sent on WhatsApp a new zip file, right? Download it. Go to that demo 0, run the demo 0, and then see if you can do demo 1 by your screen. There's all the instructions, everything required. We'll of course explain, but see if you can go slightly ahead. And citation within some of you can finish that, you can be part of the TM. Yes. Demo 0 done. Excellent. Have you copied the demos files? Go to demo 1. Okay. Once let me know once demo 0 is. What's the problem with you? Internet access. My friend, internet access. It will be slow. He can help you too much faster. Yes. Demo 0. So look at the new demo files that sent on WhatsApp. Copy all those files to demo directory. Rerun the demo 0. Rerun the demo 0. And then run demo 1. See how much you can proceed. The instructions are there. The theory is already covered. We will again tell you what to do, but this is telling you. Right? Try leading yourself a bit. Everyone? Good mark. Demo 0 done. Runs. What about your friends? What's your you downloaded them. Oh. Correct. Okay. I'm just thinking, so the demo 0 is done. I want to explain a bit about the AST and all that before we go to the so we switch the machines.
You can start with some explanations.
Yeah, that's what it is. So the tutorial has explanations for demo 1. So remind me, what does demo 1 currently do?
It's the same demo 0 you are
Demo 1.
the demo 1 from the back of the geo.
Same.
Yeah, same thing.
Oh, perfect. Okay. Okay. All right. While you are kind of finishing your installation and running the demo 0, let's go slightly bit forward. Okay. See, you already are familiar with the idea of an AST, right? Abstract syntax tree. Let us say my grammar says while statement for C is the while token, left bracket, an expression, right bracket, and a statement, right? And statement could be a compound statement, an if statement, an expression statement, etc. So this grammar, from this grammar, we would have generated a parser. Using this grammar, we would have generated a parser, right? If this is the input code for this grammar, then an AST will be generated that looks like this. A node called while statement, which has how many children? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Every non-terminal will have further children. Expression has further children. ID less than 11. The statement, depending upon what it is, I will have further down. Is this idea of AST clear? How many children does the while statement have? While statement has a token, the predicate, the body. Correct? Is that fine so far? IMOP, given a program, as usual you build the parsed AST, and then you can say, hey, go get me a while loop statement, a while statement. In the while statement you can say, hey, you know what, get me the body of the while statement, get me the predicate of the while statement. Okay, we will see how to do that. So if IMOP has one more interesting facility. You give any string, quoted string, okay, give it to IMOP, IMOP will give the AST for you. So if you take this program and use this command called program dot parse and normalize input, it will take an argument. If this is the program, pass this to the parse and normalize, it will give the AST. The convenient thing of this is the parsing and normalization has happened behind the scene, right? So this parse and normalize is something that we will use. So you can, in your demo, if you look at your demo 0, there is a main function. There you can do program.parse normalize input, and this args is the name of is a command line file name. It's a file on your file system. So if you give that file name, it will create the AST for you. Okay. So what does this do? It creates the AST. Pay attention. It creates the AST and stores it in program.root. Program is a global variable. Program.root stores the AST root. Okay. This command line arguments gives me the file name. So when you run Java, either in Eclipse, if you just run, automatically it does it. Otherwise, if you say Java IMOP and specify the file name, okay, this command line arguments are in here. Okay. How did I get this .i file? Let us say I have a C code which is in .c. To a .c file, when you invoke it with minus capital E, do you know what it does? Anyone? How many of you know what are C macros? Hash defines? You know, right? You also have this hash includes. They are all macro processor directives. Okay. If you run with GCC minus capital E, GCC will do the macro processing and dump the pre-processed code in .i file. Okay, for example, let us say I have okay, let us say I'll remove this thing, hash define good as 0, okay, and I write int x equal to good. Okay, that's my program. Now if you see cat t1.c, this is my program. Thank you, ma. Let's say this is the code I have written, hash define good as 0. In the main code I have int x equal to good, nothing more, no print, nothing. If I now do gcc minus capital E t1.c, you know what it will do? It should run. It replaced wherever the good is there with 0. This is macro processed. The word good doesn't appear anywhere. Capital E. Okay. Let us say I have I also have, let us say, hash include stdio.h. You know what it will do? It will bring in the stdio.h into this and dump everything in one go. So if I do this again, this time I am passing it through a pipe. See that stdio.h has lot of type defs, lot of structs which we don't need, but the last part is still the same. That's my main. So whatever that include, that has been macro expanded. Okay. Huh? No linking, ma. There is no linking we are doing here. Minus E only does macro processing or expands the macros. E for expands. All macros have been expanded. Is that fine? Minus E switch. You can write your own C code and use with minus E. Okay? And now let's get back to this. So what I was saying, the input to IMOP is a macro processed file. Okay? Okay. Here is a simple way. Here is a simple program we want to try out. What's the program we want to try? You give me a file name. This is a C code. I want to simply print it back. What do I want to do? Simply print it back. What I'll do, let's see. So let's say this is my AST. So this is same, parse and normalize input. Okay. Where is the AST stored? In program.root. Program.root has the AST. Now what I'll do? System.out.println program.getRoot. It will print the full AST input back. I can say dump snapshot or dump root to a file called f1. It can write to a file. Okay. This will dump to standard output. This will dump to any file of your choice. Is this clear so far? Any questions? You may see, hey, there are so many new commands here. This, it's okay. For each of the demo sessions, we have clearly told you what all is required. We present it in one file. In a real compiler, what will you do? There is typically manual. From the manual, you learn important things and keep on slowly increasing your knowledge base. For our tutorial, we are providing everything in the same demo file as comments. If you look at demo1.java, you will see a lot of comments. Use this for this, use this for this, use this for this. Okay. Are you fine with this so far? Any questions? What's your name, my friend? Kshitij, are you fine with this? What does it do? Parses and then builds the AST. Okay. AST is stored in program.root. What is this doing? Ma, what is this doing? What is this statement doing here? Oh, okay, those who are not familiar with Java, system.out.println in Java is C++ cout. Okay, or C printf with a new line. Okay, system.out.println. This will print the full the AST starting with root, and this will dump the same file to. Remember, IMOP is a source to source transformer. It takes C/OpenMP code as input. You can do some transformations and dump back the code back to C. So that way, when you do any transformation, loop unrolling, loop fusion, you can actually see the code directly, right? Okay. With each AST node, we can invoke a method called getInfo that gives you lot of information about the AST. Okay. On Eclipse, if you take any AST node and do getInfo, you can see what all methods you can invoke. Let us say I have an assignment statement. This whole assignment statement is a node N1. Okay. The right side, this is a declaration and initialization, right? It's a statement where I am declaring something and initializing. For this whole thing, there is a node. For this thing, there is a node. For X, there is a node. For each part, there is a node. So what happens? N1 is a declaration. If you do N1.getInfo, it is giving it. This one will have information about N1, and there is a method called getInitializer. It will give you N2. Do you see what I am saying? I have a node, I am doing getInfo. This getInfo is a method that you will use quite often, and depending on what the AST node is, since N1 is a declaration, it has an initializer. If it is a while loop, it won't have an initializer, it may have something else. Depending on the statement, you can do different things. Here is one more. Let us say N1 is a while loop. Then I can do N1.getInfo. I can not only, so on this while statement info, there is a method called unroll loop, which is already implemented. You will also implement unroll yourself, but there is already a method called unroll loop. If you tell how many copies you want to make, let's say you want to say unroll by 1, original code, the predicate once more, right? And this whole thing is, I mean, now you can get this thing as an AST. You can get this thing as a string or an AST. It's not yet replaced. This is not changing yet. Okay. There is one more common thing before we go to the demo one. There is one more common thing that's very much required in any writing a compiler. Going over the statements. If I have a set of statements, I iterate through all the statements. I iterate through all the while loops. I iterate through all the assignment statements. I iterate through all the functions, right? Because if I want to say do some loop operations, I have to iterate through all the loops, right? Things like that. So we have, for example, you can do something like this: program.getRoot. This will give the root of the AST. On the root, you do getInfo.get all function definitions. You know what it will do? It will give you a list of all the functions. You can do something like this. Let's say I have an AST. Any AST could be a root or something else, I don't care. I'll do n.getInfo.get statements with a certain label. In C, you can have labels, no? So if all the statements with label L, some specific L you want, it will give you the list of that. Okay? I can say give me all the if statements. Get exact enclose given AST n What type of statements I am looking at? All the statements which are of type if statement. It will give you all the if statements. You can do all the if statements, all the for loops, all the, right. So you need to know what are the different classes. That's not too difficult. We'll tell you how. But the point I'm trying to say is that you can get a list of blah. You pick what you want and then you can iterate over them. Okay. For example, let's say I want to print all statements having a given label. What I'm doing, I will do program.getRoot.getInfo.get all function definitions. Okay. You will see in demo 1, if you open demo1.java, on top this is one of the instructions given. It will give you a list of all the functions. In that function, I want to say statement function.getInfo, get statement with label. You fix a label name. With that label, how many statements can be there in a function with a label? Each label is unique. So I will get a single statement. There are two possibilities. Statement is null. Such a label doesn't exist. Statement is not null. Such a statement exists. Print. Pay attention to the following. I am getting in, by this for loop. This way of writing is kind of C++ allows it, Java allows it. It says func is of type function definition, and when I write func colon this, it means this will give me a list. The right side is giving me a list. Func will iterate over that list. So this for loop is basically iterating over all the functions. This for loop is iterating over all the functions. All the functions of under program.getRoot, that's the given node. Instead of program.getRoot, you just pick some other AST, it will go to that. Similarly, the get statement with label gives me one statement, I can print it. Okay. Do one thing. So now open your demo 1. Maybe I should have, why don't I just open it, or do you want your machine only? So open demo 1. So if you look at demo 1, we want to invoke parse and normalize. We want to traverse all while statements. We want to query CFG predicates. CFG is control flow graph, predicates and loop bodies. Traverse all the if statements. Identify if statements without an else body. Okay. Now you will see there are to do 1, T1, T2, T3. Under each to do, you have to insert your code. We will be coming and checking on each machine. For each to do, you have to insert code. We have already given an input file. Okay, some input example is already given, and yeah. So for each to do, if you are in doubt what to do for the to do, look at these things. This may help you. Okay. I am leaving this at this time for bit underspecified. You read it. As you keep asking questions, we will keep explaining. Right? Coffee time. Okay. Should we do finish demo one and then go to coffee, or have coffee and how sleepy are you feeling? Your choice. I mean, if you want to finish demo one and go to coffee, or have coffee and then come do demo one. There are only two options. Finish the demo and go. Demo one and then go for coffee, not go home. We have more demos, but finish the demo one, have coffee first. Okay, let's have coffee. Those who want to continue, we are here. Come. Bolo.
Zero and it's weird. I don't know what's happening. This is a weird. Zero.
Yeah. Sorry. Bolo.
Now, when I try running demo one, and this keeps dropping up, I still proceed.
Yeah, because demo one nothing is there, no? So go to demo1.java.
Okay, so we have to insert statements.
Yes, ma'am. With this demo1.java, you have to edit. Demo 0, you didn't have to do anything, right? You just ran. Demo 1, you have to write the code now. You're now writing a pass in the compiler. Whatever you write will be plugged inside the compiler.
So the image is, so the output we view through the dot graph.
No. Leave that's different. The dot graph output dump we are not doing now. So go to SRC. Where is SRC? Go to SRC. Did you copy the demo files I sent you?
ACM Winter.
Yes. Yeah. Now here come to demo 1. There are a lot of to-dos.
Yes, edit it and make it work.
Yeah.
And where do we see the output?
You run it, it will show up here.
So just give run here and okay.